All right, next section in this chapter P, section 5, is going to be adding and subtracting rational expressions. All right, so when you're adding and subtracting rational expressions, right, and you guys do this all the time with numbers, you need to make sure that they have the same denominator. All right, factor everything first. Sometimes when they get especially large, you can factor and make the initial fraction a little bit simpler. And then once you factor and simplify, then you would find the least common denominator. All right, so every term and expression to the highest degree. And then you're going to multiply each term by what is missing from the denominator, right? Might seem a little strange, but I'll do that in the next example. From there, you would add and subtract your numerators, and you would use the least common denominator as your denominator. All right, so starting with number 1, a lot of us can do this very easily, right? So I know a lot of us in class were able to do this really with no issues. A lot of us could just add these and knew that you had to multiply the top and the bottom of this one by 3 and the top and the bottom of this one by 2. All right, but think about it like this, right? So 2 and 3 don't share any common factors at all. So the only option that we had to be able to add these was to multiply by what each fraction didn't have in the denominator. So in other words, multiplying it by each other, right? So 2 and 3, I would multiply them by each other to get a common denominator of 6. All right, and then on the top, we would do 3 times 1 and 1 times 2, which would get you 3 plus 2, so 5 over 6. All right, super easy. All right, but we're going to take that same idea and do it to maybe some more complicated expressions. All right, so the next one, 1/6 plus 1/12. This is one where we don't want to multiply by each other, right? You probably could do 12 and 12 on the top, 6 and 6 on the bottom. But I think a lot of us in class, as I was doing this, were able to recognize that all we had to do was multiply 6 by 2. Right, so I'm not going to do this. I could get a common denominator of 72 and then get a large numerator and then try to simplify that. But that's a lot of work and you don't need to do that. But again, what I would do instead, notice that 12 and 6, they share a factor of 6. 12 can be written as 2 times 6. All right, and then when you look at it like this, they have the 6 in common, but they don't have the 2 in common, meaning I just want to multiply this fraction by 2, right? That's the only thing I need to do to get them to have the same denominator of 12, right? Because 2 times 6 here is going to get me 12. But whatever you do to the top, whatever you do to the bottom, we have to do to the top. So we end up with 2 times 1 plus 1, right? So 2 plus 1, which is 3, right? So we get 3 over 12, which simplifying it further is 1 over 4. All right, so super easy examples to start, right? A lot of us could do stuff like this. All right, it's when it gets to expressions with variables that maybe some of us get a little confused, right? These first few are going to be pretty similar to what we just did, though. All right, the goal when adding and subtracting is to get the common denominator. All right, and when you're looking at something like number 3, number 4, notice already that these have a common denominator, right? The denominator here is x plus 1. Here it is also x plus 1. Once they have a common denominator, I can simply add or subtract the numerators. So this is just going to be 1 plus 2 over x plus 1. So 3 over x plus 1. And that's all we had to do there. All right, and we can take that same logic, apply it to number 4. This one has an x plus 2. This one also has an x plus 2. They already match, so immediately I can write x plus 2 as the denominator. And then I'm going to have an x plus 1 minus 2x minus 3 on top. All right, don't forget there is a minus in between, so you're subtracting the entire thing. All right, and then the numerator, we do want to simplify a little bit more. I can take that negative and distribute it to each term here. And so we end up with x plus 1 minus 2x plus 3, right? Just changes the sign of everything in the parentheses. And then we still have x plus 2 on the bottom. All right. And then lastly, you just want to combine like terms on top. X and negative 2x is going to get you a negative x. 1 and 3 is going to get you a 4. All right. So I get negative x plus 4 over x plus 2. Nothing more we can do to that. I would leave it alone. All right. So same exact idea when you have variables in the bottom, but you'll see in the next slide, some of them get a little bit more complicated. All right. So stuff like this. This first one's not too bad. I have 1 over x and 5 over 6x. So kind of the same idea as what I was just talking about. You're looking and seeing what they have in common. The 1 over x and the 5 over 6x, they share the x in common. So I know that I'm for sure going to have an x in my denominator. But notice 5 over 6x has a 6, but 1 over x doesn't. So I know for sure I'm going to need the 6 as well. So all I have to do is multiply by 6 on the top and on the bottom. And then doing that, I get 6 times 1, so 6, plus 5. And so I get 11 over 6x. All right, and that's all we had to do, right? But we didn't have to multiply. I know what some people like to do is they like to multiply by each other, right? They like to do this one maybe by 6x, and then this one by x. All right, if you did that, you would have gotten a bigger expression on the top and on the bottom, and then you would have to factor it and then cancel things out even more, right? Try to avoid that altogether. All right, but when you look at something like number 6, this one doesn't have anything in common in the bottom, right? You might be thinking they have x and x in common. Like, yeah, it does look the same, but we're looking specifically for common factors, all right? Now, x doesn't have any other factors other than itself, all right? And the same thing with x plus 1, right? X plus 1 is its only factor. So that means in the bottom, this is a case where you're going to multiply by each other. So x and x plus 1. If that's confusing, think about it like 1/3 plus 1/2, right? One of the very first examples we did today, all right? They didn't share any factors in common, so you multiplied by 3 times 2 to get 6. All right, that's kind of what we're doing here, all right? So I know I need an x and an x plus 1 in the denominator, so you're going to look at what factor is missing from each of them. So if you look at 1 over x, what factor is missing for it to look like this as the denominator? It's missing the x plus 1. So I can multiply the top and the bottom by x plus 1. And then doing that, 1 times x plus 1 is just x plus 1. All right, and I can do the same thing with this next fraction. What is 1 over x plus 1 missing for it to look like this in the denominator? And it's missing an x. So I can multiply the top and the bottom by x, and then 1 times x is x. All right, so plus x. And now I have everything under a single fraction. I just want to combine like terms on top, and then you would get your final answer, right? X plus x is going to get you 2x plus 1 over x times x plus 1. All right, so same idea for these next few examples, right? So 1 over x plus 2, 3 over x minus 4, think about what factors they have in common. And really, they have no factors in common, right? X plus 2 and x minus 4 are their only factors. So I know for sure in the denominator, I'm going to want an x plus 2 and an x minus 4. All right? So you're looking one by one. I'm going to look at this fraction. What does this need in order for the denominator to look like this? All right? It needs an x minus 4. So I'm going to multiply the top and the bottom by x minus 4. All right, and then 1 times x minus 4 is just going to get you x minus 4. All right, and then you're going to do the same thing with this one. 3 over x minus 4, we're missing an x plus 2 for it to look like this on the denominator. So I'm going to do negative 3 times x plus 2, right? I'm going to keep that negative with it, and then I'm going to distribute that negative 3 to x plus 2. And so I get a negative 3x minus 6. And then x minus 3x is going to get me a negative 2x. Negative 4 minus 6 is going to get me a negative 10. All right, and that's as simple as the top gets. You can leave it just like this. You don't have to FOIL the bottom or anything. All right, this would be our final answer. All right, another thing that would be equally correct is if you decided to take out a negative 2 from the top and you're left with an x plus 5. All right, that's also fine. I don't mind. It doesn't really help us here in terms of canceling anything out, but this is another equally valid answer, right? So that's perfectly fine. all right? And I can do the same thing for number 8, all right? Notice that the denominators here are not the same, but they also don't share any common factors. X minus 3 and 3x plus 4 have nothing in common. So I know for sure I'm going to want to multiply them by each other. So I'm going to want an x minus 3 and the 3x plus 4 in the denominator. And again, you're going to go one by one. I'm going to look at this first one. What is this first fraction missing for it to look like this? And it's missing the 3x plus 4. So I'm going to do x times 3x plus 4 on the top and on the bottom. You don't have to write it on the bottom just because we already established what the denominator will be. All right, so I know on the top I'm going to want to distribute that x. And that's going to get me a 3x squared plus 4x. You're going to do the same thing with this one. What is the 3x plus 4 missing for it to look like this? It's missing the x minus 3. Again, I don't have to write it on the bottom because I already know that this is going to be my denominator. So I'm going to take that negative 2. I'll keep the sign with it just to do it in less steps. All right, but I can take that negative 2 and distribute it, and then I get a negative 2x plus 6. All right, and then simplifying this, I'm going to get 3x squared plus 2x on top, right? We combine like terms, plus 6 over x minus 3 times 3x plus 4. All right, and that's all we have to do to that. All right, so same thing with number 9. There's nothing special with number 9. It's going to work exactly the same as the others have. All right, so this is going to equal something. 2x minus 1 and x plus 2 don't share anything in common. They're both fully factored, so I'm just going to write both of them. And this is going to be what I want my denominator to be. So looking at the first one, x over 2x plus 1, it's missing the x plus 2. So I'm going to multiply that top by x plus 2. And I'm going to distribute that x, and I'm going to get an x squared plus 2x. All right. Same thing with the bottom here. All right. X plus 2 is missing a 2x minus 1. So I'm going to multiply the top by 2x minus 1. All right. And then I can take that negative 1 and distribute it to each of these. This is going to get me a negative 2x plus 1. All right. And then lastly, we just want to simplify the top. 2x minus 2x cancel out. And so I'm left with an x squared plus 1 over 2x minus 1 times x plus 2. Nothing more we can do to that. That's going to be our final answer. All right. Where it gets different is the last two examples. All right. So you might notice that number 10 and number 11 also look like they have nothing in common. All right, it may look like that, but before you draw the line and write x squared minus 9 and x plus 3, right, we want to make sure that these are fully factored and that we're not repeating any factors. All right, so that was what the very first slide was saying. That's why in the very first slide, one of the steps was factor, right? So I'm going to erase this. We don't want to do this right away. What I want to do first is factor. And notice that this can be factored. X squared minus 9 is a difference of squares. It's going to be an x plus 3 and an x minus 3. All right, now let's look at what they have in common. It looks like they have an x plus 3 in common, right? That's the same here as it is here. So I'm only going to write it once, right? If it shows up under both denominators, it already is a common denominator. I don't need to write it twice, all right? But the least common denominator, it needs to make sense for everything, right? So this x minus 3 is there. It's not here, but I would still need to write it in my common denominator. So I would need this x plus 3 and the x minus 3 as my least common denominator. All right, and when we do our same steps that we did before, right, we're going to look at the first fraction, and I'm going to see what is this missing in order for it to look like this. It's not missing anything, right? So I would keep the 2 up top and not do anything to it. I don't need to multiply it by anything because the denominators already match. But over here in the 4 over x plus 3, only part of it matches, right? The x plus 3 matches. I would still need to multiply the top by x minus 3 in order for it to fully match. All right? So then on the top, I can distribute that 4, and I would get a plus 4x minus 12. And then combine like terms on top, I would get a 4x minus 10 over x plus 3x minus 3. And so I can leave it just like that. All right. Hopefully not too bad. Hopefully we can see that we didn't need to repeat factors, and we can see why that's the case. If not, let's try the same thing with the next one. All right, so if you look at this next one, 3 of them, it's going to work exactly the same way, right? I'm going to have one single denominator, but before I go ahead and realize that none of them match, I would factor, right? So I would need an x plus 1 and an x minus 1 here, right? That's the difference of squares. And now things match, right? X plus 1 matches here. If it matches between two fractions, I only need to write it once. All right, same thing with this one. The x minus 1 matches. I only need to write it once. I don't need to write it twice because it's under two fractions, right? If it matches, just write it once. And it looks like with that, that accounts for all of them, right? In the denominator here, I don't have any other missing factors, right? So this is going to be my least common denominator. And then I'm going to go one by one, right? Let me look at this fraction. The x plus 1 on the bottom is missing the x minus 1. So I'm going to multiply by x minus 1 and distribute, and that's going to get me a 2x minus 2. All right, and I can do the same thing with the next one. This x minus 1 on the bottom is missing the x plus 1. So I'm going to multiply by x plus 1, distribute, and I'm going to get a plus 2x plus 2. All right, and then this on the bottom has the x plus 1 and the x minus 1, so I don't need to do anything to it. I'm just going to add the 1. All right, and then simplify this fraction. 2x plus 2x is going to get me a 4x. Negative 2 plus 2 cancels out, and then I'm left with a plus 1. So I'm left with 4x plus 1 on top, and then on the bottom, I have an x plus 1 and an x minus 1. All right. So those are all the different cases when you're adding and subtracting to look out for. All right, so just be careful. Some people I find make a lot more work for themselves than they need when they don't factor, right? Because you could have written all of these denominators under a single fraction, but we see that we didn't need to do that, right? We just had to write it just enough times for it to fully match across all of them. All right, so hopefully this lesson's okay. I know it's a little bit more work than the multiplying and dividing and the simplifying, but still an important skill. We'll need it down the line.